Colpitts oscillator. In this oscillator, two capacitors are placed across a common inductor L. You're looking here the two capacitors C1 and C2, and there's an inductor L, and it is centrally tapped. Two capacitors are centrally tapped. The tank circuit is made up of, here is the tank circuit, okay, and also called the tuned circuit, C1, C2 and L. The tank circuit is made up of C1, C2 and an inductor L. The frequency of the oscillation is determined by using the values of C1, C2 and L and given by the frequency. This is the formula of the Colpitts oscillator, 1 over 2 pi under root L into Ct. So Ct is the, the combination of the two capacitors. Circuit operation. Okay. When VCC supply is connected, like this a supply, it is connected to the Colpitts oscillator. It is given to this circuit, oscillator circuits. Then current begins to flow, and the capacitor C1 and C2 begins to charge. So charging starts. Okay, and charging starts, there is an inductor across the combination of the two capacitors, and setting up the oscillations in the tank circuit produces oscillations. So oscillations built up by this tuned circuit. Okay, and this is the tuned circuit. The capacitors are centrally tapped. Okay, output appears across, between earthing point and at the collector. At the collector and the earthing point, the output appears. So this is, a phase shift 180 degree produced by the transistor. Common emitter configuration produces 180 degree phase shift. And another phase shift is introduced by the tuned circuit or the tank circuit, again of 180 degree. Okay, so this tuned circuit also produces 180 degree phase shift. Total becomes 360 and is applied to the base, and the signal comes in phase. So 180 degree by the common emitter, 180 degree by the tuned circuits. So total becomes 360. 180 phase shift by the transistor, 180 by tuned circuit, total phase shift becomes 360. So there's a positive feedback. Positive feedback is properly phased to produce continuous undamped oscillation. This becomes positive feedback as the signal comes in phase. Okay. So total is the 360 and applied to the beat. Now below there is the equivalent diagram for the Colpitts oscillator. Now there is a basic difference between Hartley and the Colpitts oscillator. In case of Hartley oscillator, there were the two inductors, two coils centrally tapped, and there were one capacitors across. But in case of the Colpitts oscillator, it's the other way around. Here the two capacitors are centrally tapped and there is an inductor placed across it. This is the equivalent diagram of the Colpitts oscillator. Now here is the input impedance, HIN, current flowing is IB, HRA is input impedance for the common emitter configuration, and current flowing at the slope is IB, which is equals to, let me call it I1. Here it is a voltage source. It is voltage source, and HRE into V2, HRE This is positive, negative. Okay. And current flowing like the clockwise direction. Now here it is not a voltage source, actually current source. So that's why there should be an arrow. And the current source is HFE into I1. HFE is the forward current ratio, which is by definition I2 over I1. Okay, now this is 1 over HOE, that becomes a resistance. HOE is output admittance, and for common emitter configuration, and 1 over HOE is the resistance. Now voltage between the 2 points is V2. There's the output voltage. This is the output voltage, okay. This is the loop number 1, loop 2, loop 3. Okay. Now this is the current source, and let it is converted into the voltage source. How? The current source multiplied by this current, okay, multiplied by the resistance, which is 1 over HOE. Now this becomes the voltage source. By using the Thevenin theorem, there's a voltage source, and then the parallel resistance 1 over HOE now comes in the series, in a series circuit with the voltage source. So this is, this is the current source, and then the 1 over HOE. This resistance comes in series with the voltage source by Thevenin theorem. So current source is now converted into the voltage source. So voltage between the 2 points is V2. Okay, and current flowing is here I2 along anti-clockwise direction. I2 is current flowing. Here in this loop, clockwise current flowing is I2. Now here the current flowing is I3 along this loop in clockwise direction. Okay, now the voltage across 1 over HOE. 1 over HOE is a resistance, and current flowing is I2 along anti-clockwise direction. So the current enters, that end is positive, and leaves it is negative, and here is minus plus. So there are the two voltages. One voltage across 1 over HOE, that is this is I2 into 1 over HOE. So this is one voltage, and the second one is, which is opposing in nature to the first one. So that's why negative sign, and second voltage is HRE into I2 upon HOE. This is a second, which is a voltage source. So minus sign because two are in opposition. So let's the voltage up here, voltage develops across HRA is R1 into HRA. So this is HRA into I1, the first voltage. So now the next one, here it is a plus sign, and here it is a minus sign, and second here is a voltage source plus minus. So plus minus, again plus minus, that positive sign between the two voltages, HR into V2. Now coming the capacitor. Now along the capacitor the voltage is minus JXZ1 and R1 minus I3. Now let me explain why it is minus J. You know, the capacitive reactance, it is equals to 1 over JC omega. J is operated because of the phase. Phase is related to the capacitor. So So multiplying and dividing by the j operator, and j into j becomes minus 1. So minus j into j in the denominator minus 1. So it is minus j over c omega. Okay. So minus j upon c omega. You can say minus j into 1 over c omega, let me call it xc. 1 over c omega, let me call it xc. So it is minus j into xc. So that's why there is minus j into xc. Now I1 minus I3, why there is a negative sign? Because I1 it is along, we are traversing, it is I1, and I3 is coming along opposite in direction. So substituting V2, okay, the above equation is rearranged and written in form of the components of I1, I2 and I3. So I1 is here, I1 is here, so and I1 is also here. So I1 is taken as common, I2 is here, and as well as, so I2 is only for the single term, and I3 is, it is of this term, so this is of I3. Okay, now we're coming to the loop number 2. So coming to the loop number 2, so the current flowing is like anti-clockwise direction. Here current is I2, and here the first voltage appear across 1 over HOE. So I2 into 1 over HOE. Then second, this is the voltage source, and both are in opposition, so that's why negative sign. Now the coming, both are in opposition. Now then coming the capacitor, coming to capacitor, as I explained above why it is minus j. Okay, so minus j into xc2. Now this is capacitor number 2, and I2 is flowing along our direction, I3 also. I2 and I3, both enters both through the capacitor. It is the same direction, that's why the plus sign, I3. Now let me rearrange the this equation in terms of the components of I1, I2 and I3, and then this is the equation in terms of the component of I1, I2 and I3. Now coming to the loop number 3. Okay, so loop number 3, first of all coming to this capacitor C1. So capacitor C1, why this is minus j operator, I explained above. And I3, here current flowing is I3, but I1, it is in opposite direction, that's why I3 minus I1. Okay, that's why I3 and minus I1, both current are in opposite direction. Then coming to the capacitor C2 again minus j operator, and XC2 current flowing along the same direction here. I3 and I2 both are along the same direction, that's why the positive sign. Okay, minus j I explained above. Then coming to the inductor, plus j XL, and then the current flowing is I3 only. The current is I3 and it is equals to 0. Now rearrange the terms in terms of the components of I1, I2 and I3, and this one is the equation. The equations are rearranged in terms of the components of I1, I2 and I3. We are having the three equations and having the components of I1, I2 and I3 written in terms of the determinant. The equations written now in the form of the determinant and the components of I1, I2 and I3, that mod, and it is equals to 0. Solving the determinant, first term bracket 5th into 9th term minus 6th into the 8th term. First term bracket 5th into 9th minus 6th into 8th. Okay. Now minus second term, break it 4th into 9th, minus 6 into the 7th. Okay, minus second term, bracket 4th into 9th, minus 6 into 7th, bracket close. Plus third term, bracket 4th into 8th minus 5th into the 7th. Okay, again plus third term, bracket 4th into 8th minus 5th into 7th. Simplifying it and equating it equals to 0. Equating the imaginary part, that is the terms containing the G operators, and equating both sides, the term having the G operators. multiplying each term by omega square over L omega, or multiplying each term by omega over L, multiplying each term by omega over L. The above is a quadratic equation, quadratic in terms of xc2. Okay. solving for the quadratic equation.